Working Cows Podcast, episode 303. This episode is brought to you by Farming Without the Bank.
Welcome to the podcast that gives producers a platform to discuss and share paradigm-challenging practices. Practices that have increased the effectiveness of their operation and the joy that their families have received from this lifestyle.
Howdy, everybody. This is Clay Connery, host of the Working Cows Podcast, recorded exclusively in the C90 Ocean Minerals Studios. And this episode is brought to you by Farming Without the Bank. None of you are ranching like you did 100 years ago. Why are you financing it like you did 100 years ago? The biggest part of your operation is the money that runs through your hands, and you let someone else control that. The bank gets the final say in what you get and when you pay it back. For many, this is a great relationship, until it's not. Farming Without the Bank shows you how you can take back control of your money so that you can make the bank plan B instead of plan A. This is done by you creating your own banking system that you own and control. To learn more, tune into the Farming Without the Bank podcast and go to farmingwithoutthebank.com to get the book. Once you've read the book, Mary Jo will meet with you one-on-one and help you determine where and how to get started. She will most likely also touch on some estate transition ideas, financing ideas, business growth or startup ideas, and many other things that she has experience with from helping thousands of farmers and ranchers. So go to farmingwithoutthebank.com today to get the book and subscribe to the Farming Without the Bank podcast now. Very excited to be joined today by Don Day. Don is a private meteorologist, and as I've said a couple of times in the outro to recent episodes, I don't know what the Venn diagram of listeners between the Working Ranch radio show and the Working Cows podcast is, but I heard Don on the Working Ranch radio show a year or maybe more ago now, and Derek Schwannebeck, a friend of the Working Cows podcast, recommended Don as a guest longer ago than that. And so have been wanting to get him on for a long time. Finally reached out to him. He was very accommodating, and we got together and set this up. And we're going to talk today kind of about the long-term predictability of weather patterns and some of the big picture things that are playing a role in influencing the way that our weather patterns play themselves out. And so very excited for this conversation today. Don, thanks for joining me today on the Working Cows podcast.
Thanks, Clay. Thanks for having me.
Really have appreciated your work. As I said just a few moments ago, I really have appreciated your work as far as making us aware of winter weather and those kinds of things coming our direction over the calving season. Many of my neighbors are in the thick of it, and so it's very important to have timely information. So let's just start off there, talking a little bit about kind of what it is that you do and kind of some of your goals as far as forecasting and warning people about what's coming.
Sure. I'm a little bit of a different cat. I'm what's called a private meteorologist. When I graduated from the University of Wyoming in the early 90s, I was all ready to go to the National Weather Service, but I got caught in a federal hiring freeze. And so while I was waiting for the freeze to go off, I started my own weather forecasting business and have been doing that since. I'm on my 32nd or 33rd year. And I decided to focus on one part of the country and try to create a business where people would actually pay me to be wrong half the time. But it's been a labor of love because I love the weather and it's immensely challenging. And we live in the part of the country where, and this is true everywhere in the United States, but especially in the Western High Plains and Rockies, where it's extremely challenging and really affects everybody's livelihood.
Yeah. What are some of the things that go into making this unique as far as the challenging nature? Is it topography or what is it that makes it so challenging sometimes to predict the exact path of a storm or when and where it's going to hit?
Yeah, no, a lot of it is topography. In fact, topography probably plays the biggest role on everybody's local weather, your local microclimate, where are you in a valley? Are you on a ridge? Are you in a river valley? Or all of those things add up throughout the course of the year to make significant changes in how storms behave as they go through a region. But for a lot of the United States, we're square right on top of what we call the mid-latitudes. We're exactly in the middle between the equator and the North Pole. So the jet stream throughout the course of the year loves to be in the mid-latitudes more often than not. So that brings weather our way. And one thing about the Western United States, which makes it really tricky, is that we have three air masses that really play a huge role. One is the Canadian air masses that come out of central and western Canada, the Pacific air masses, and those Pacific air masses come in different flavors. We have Gulf of Alaska air masses. We have air masses that come off the Pacific Northwest and off of California. They're all a little different. And then we have desert air masses that will come up out of the southwestern United States, and they all sort of want to convene into the western half of the United States, really from the central Dakotas west to the west coast. It's a real melting pot of these air masses. Now, the rest of the country, well, they deal with Canadian air masses too, and they deal with Gulf of Mexico air masses, and there's some impact with the Atlantic. But those air masses tend to be a little more separated throughout the course of the year. While in the West, we have those air masses competing, and then we have lots of canyons, lots of mountains, lots of valleys, lots of canyons and ridges and arroyos and big river valleys and systems that all interact with the atmosphere to make it really quite complex.
Sure. One of the things that we talk a lot about here, I've got listeners in all 50 states and in a few countries around the world, but one of the things that we talk a lot about here is kind of the difference between ranching in the West and ranching in the East, and where I kind of draw that line is the 100th meridian. And so what is it about the 100th meridian, or why does America as a whole pick up moisture going east? Why is it getting, well, and I think the Rockies probably break up a lot of that, and it's wetter west of the Rockies and then drier east of the Rockies. But then once you get past that 100th meridian, it starts to pick up moisture. Do you have a sense of why that is?
Yeah. And we talked about air masses, and it's all about the Gulf of Mexico. Really plays a huge role, because if you look at the water temperatures that are off the coast of Texas and Louisiana and Florida all the time, they're really never colder than the 70s, and they get quite warm in the summer. And that just releases a tremendous amount of water vapor into the air. And so as we get into the spring and summer and fall seasons, that Gulf air just goes up into the Corn Belt in the southeastern United States and then goes east across the rest of the country. It makes it very difficult, because of the westerlies, for that Gulf of Mexico moisture to get pulled back into the western states. Now, sometimes it happens with big storms, but not very often. And then you brought up the mountains. I like to use the analogy that the mountains are like the IRS. So as storms come off the West Coast, it's like the gross on your paycheck. By the time these storms cross all of the Sierra Nevadas, the Cascades, the Rockies, the Great Basin and Range Mountains, by the time they get to this narrow strip east of the Continental Divide, these storms are starved for moisture. So that's why you inherently have this dry slot east of the Rockies that go from Canada really all the way down to Mexico. Then as you go east past that 100, as you described, that Gulf of Mexico air mass starts to play a big role. Like they joke around, if you drop a seed in Iowa, it's going to grow. Mm-hmm. If you drop a seed in Western South Dakota, it's going to blow away.
Yeah, for sure. So we're kind of still on this preliminary line of questioning here. I'm more satisfying my curiosity at this point. But in 2019, we were incredibly wet. Was it the same in Wyoming? I know that in Western South Dakota it was. Was it the same in?
Well, yeah. In fact, it was one of the wettest years in the lower 48 on record. And it wasn't just United States. It was extremely wet over in Europe. England, the UK, parts of Western Europe also had a very wet spring and summer. And so without a doubt, that was wet just about everywhere. That was a big El Nino year. And I always like to point this out is that globally, these Pacific cycles play a big role. And sometimes it's the opposite. When we're wet, like we were in 2019, 2019 is when Australia had drought and all their fires and wildfires. And so you'll see the pendulum swing like this across the globe with these wet and dry periods. And certainly 2019 was one of those very wet periods. And it's been so dry here over the last 3 years, everyone forgot how wet 2019 was.
Yeah, it's kind of unbelievable that it was just 3 years ago.
Right.
Yeah. But so, yeah, that kind of puts us on the track of questioning that I really wanted to talk to you today about. Heard you on the Working Ranch radio show some time ago and kind of wanted to take a deep dive and I don't know what the Venn diagram of listeners between my show and Working Ranch is necessarily. So wanted to kind of just expose that content to my listeners as well. And then hat tip to Derek Schwannebeck, who told me I should reach out to you a long time ago, and I hadn't gotten around to doing it yet. But so here we are talking about this, and I think one of the terms that you used in the course of that Working Ranch show was that you are an analog meteorologist. Can you kind of define that term and then contrast it with others as well?
Sure. Yeah. I mean, what this means is, and this is something that I sort of worked myself into it in my career. Simply put, what analog weather forecasting is using past historical trends to help us give insight into the future. And what it means is before we even start to look at computer modeling, which is very tempting to do, which with all of our fancy high-speed computers and things that we can do now, what I found out, and I found this out the hard way, when I got into long range weather forecasting, is over reliance on the computer modeling can really lead to very bad weather forecasts if you're not careful, because sometimes the computers will put out a solution that actually makes no sense with anything we've seen historically. So I'm stealing this comment. It's not one that I came up with, but it's very clever, is that the mystery is in the history, which means that trying to figure out what's going on, there's a lot of clues historically with what happened. And one reason I got into this is, I mean, everybody runs into this. People will walk up to me and they'll say, this is the craziest year I've ever seen, or this is the coldest winter I've ever seen, or I've never seen anything like this. And then I'll say, no, yeah, you have. This happened about 20 years ago. And I'll explain to them why. And then they'll kind of scratch their chin and go, yeah, I think you're right. I think I remember that. I mean, it's human nature with weather. We're always looking forward. We're always trying to look forward because we have to, especially if you're in agriculture. But the thing is there's a lot of clues from historical trends, because what you find out, and it takes a while to be in weather forecasting before you sometimes see the forest for the trees, you find out that the weather and the climate gets a rhythm to it. And it goes, there are cycles, and trying to identify those and being able to know where you are in a cycle really helps to say, you know what, the computer models say this, but that doesn't make sense with what we've seen historically. And, this past winter is a good example. You know how many, I can count on 0 fingers how many meteorologists and climatologists got the winter of 2022-23 correct. I mean, some folks maybe have got close, kind of what the general idea was, but I don't know anybody who said that California would have record rain and record snowpack the year after the season, right after, a really severe drought. Nobody. So the computer models didn't predict it correctly. But when we started going back and looking, there were little morsels that indicated that maybe this winter was going to be a bit different.
Yeah. I think my brother and I had a vacation scheduled for our families to one of the lakes, down on the east side of California. And it was so low. We just said, nope, we're not going to go this year, and now here we are looking at, they're, probably going to have to let a bunch of water go out of that actually a reservoir, right? So they're going to have to probably let a bunch of water go out of that this year because of all of everything they've gotten over this past year. So yeah, it's pretty unpredictable. And I grew up in Western South Dakota. I think I've heard this in every state I've lived in. If you don't like the weather here, wait 5 minutes, it'll change. But so talk to me about some of the things that you do watch. You said the mysteries and the history. What are some of those trends that you are keeping an eye on, and how are they influencing your forecasting?
Well, I've become a really big believer in really paying close attention to the oceans. And when I say that, it's paying very close attention to what we call sea surface temperature, and especially the Pacific Ocean. The Pacific Ocean is the largest object on the Earth. There's no bigger anything than the Pacific Ocean. It's absolutely giant. And one thing that has really been a real important part of long-range forecasting is understanding the cycles in the Pacific when we go through these La Nina and these El Nino cycles. There's other cycles other than La Nina and El Nino, but when you put pencil to paper and you just start trying to understand how the atmosphere works, the atmosphere needs energy, just like anything else. And it derives that energy from the interaction between the atmosphere and the oceans, namely the stretch of the Pacific, which is along the equator from west to South America, over towards Indonesia, north of Australia. Well, that is not only just the equator where the Pacific is, but it's a huge fetch of water that gets quite warm during the course of the year because it's on the equator. And that warmth releases a tremendous amount of water into the air from evaporation, which then in turn generates clouds, precipitation, and storms. It causes a lot of things to start to happen, changes the trade winds across the Pacific. Basically, the Pacific Ocean, especially in the equator regions, is the best analogy I can give you. It's an engine or it's a battery. I would say the Pacific Ocean is if you were to use the analogy of a car, the Pacific Ocean's the engine of the car. The other wheels are the other oceans, so to speak, to make the car run. But the Pacific generates a lot, and it affects the whole Western Hemisphere. And understanding its little idiosyncrasies and where it is with these subtle sea surface changes of even a 0.5 degree centigrade can really make a big difference downstream. And that would be North America, Central America, parts of South America, to where if the Pacific hiccups, our weather does too. So, because if you think about it, we talked about where the sources of water are coming from. So for a lot of the Western United States, the main source is the Pacific. So as you go further east, the Pacific is less influential in the Midwest and Corn Belt, because then we're talking about the Gulf of Mexico.
Sure. And so right where I live, north of Rapid City, South Dakota, we're kind of in that zone where we probably aren't getting a lot of benefit, or maybe most of our benefits coming from the Gulf. And because you get into eastern Wyoming is where it's really dry, and eastern Montana is very dry in some places, because they haven't picked up the influence from the Gulf of Mexico, and the influence from the Pacific has kind of petered out. Is that kind of what you're saying?
That's exactly right.
So, okay. So what do you know the mechanics of what's going on in an El Nino and La Nina cycle? So I've heard it explained like how reservoirs will turn over after the winter. They'll turn over and you kind of get that murky water for a while and then it settles back down. Is that similar to what's going on with El Nino and La Nina?
Somewhat similar. And to be honest with you, what humility is one thing you learn really quick in the weather forecasting business. and the thing is there's some things we understand about the mechanics of the Pacific and the other oceans, about these changing water temperatures and what goes on. And your point about water overturning, like after a while, La Nina, when the water temperatures are cold near the equator, well, colder water is more dense, and eventually it's going to want to sink and kind of extinguish itself. But there's a lot of moving parts. We certainly know that the sun has a big influence on the oceans and the amount of clouds by that solar input. We also know that from looking at sediment cores out in the Pacific, that these cold and warm cycles, these La Niñas and El Niños, have been going on. They've been going on for a long, long time. So whether, there's no human influence causing La Niñas or El Niños. So we know they've been going on for a long time. One thing that we also need to realize is that this whole El Nino La Nina thing really wasn't discovered until the late 80s and early 90s, believe it or not. And so we're just kind of learning about these cycles. And another thing that is starting to gain a little bit of traction is that these fluctuating temperatures may be driven partly by underwater volcanic activity. The Pacific has got some extremely deep stretches of water to where we really don't know what's going on at those ocean floors. And so there could be venting, there could be these other things that go on. But we do know this. We do know that there gets to be a rhythm. And we do know that after a La Nina cycle, you're going to cycle into an El Nino, because if you think about nature always trying to reach equilibrium, the Pacific is always trying to do that too. So if you're going to have a big El Nino like we did in 2019, strong one, the natural response is going to be for the Pacific to get colder. Now, this goes into the analog part of your forecast, which is if we just had a really strong El Nino, and we know that they don't tend to go much more than maybe a couple of years, we should cycle into a La Nina. So now we're on the flip side. La Nina is fading away. So our forecast for the next 12 to 24 months is going to be El Nino driven. And I can tell you that even without even looking at a computer model. So that's kind of an example of, let's pay attention to this. I don't care what the model says. We're going to go into an El Nino cycle, and what has happened in years before like this one.
So I'm kind of a content addict, and I'm raising some content addicts at home. And so I can't remember where I heard this, if it was something my kids were watching on YouTube while I was working in the house or something that I was listening to. But somebody recently said that Point Nemo in the Pacific Ocean is the farthest point from land anywhere on Earth. And when you get to Point Nemo, you're 8 times closer to the International Space Station than you are to the nearest landmass. So that, just to put it in perspective, what you were saying about how big the Pacific Ocean is and some of those things. So and we kind of undersell the influence of the Pacific Ocean on our weather patterns and El Nino and La Nina. Is there any thinking that maybe the sun, solar minimums and solar maximums are also playing a role in this El Nino, La Nina? El Nino. I'll get that right eventually. Maybe by the time.
Oh, I know it's easy to mess them up. That's a good question, and I tell you, we're kind of swerving into a little bit of an area that is somewhat controversial. It shouldn't be, but there is a pretty strong correlation with the 11-year solar cycle and La Ninas and El Ninos in terms of when they tend to be the strongest or the weakest. I think that's the best analogy I can give you. When we go into a solar minimum, which basically means a lack of sunspots, the solar activity, the sunspot activity really drops off. And when that happens, it does affect Earth's magnetic field. And there are some studies out there. This is somewhat debated. Not everybody buys it. But there are studies out there that during solar minimums, more clouds are created, especially over the ocean basins, because the sun, with the lack of sunspots, allows more cosmic rays from outer space to hit our atmosphere, which in turn helps, let's say, instigate cloud formation more than a solar maximum. So what we tend to see, and again, that's somewhat controversial, but it's intriguing, is the fact that when we go through a deep solar minimum, and we did in 2020, 2021 and 2022, it lasted into early 22. But when we hit that solar minimum, La Nina really intensified. And what's interesting, the last time we had a La Nina this strong was about 10 years ago. And the really strong La Nina before that was about 10 years ago, which means that now that doesn't mean, what they say correlation doesn't necessarily mean causation. Okay. So we got to be careful and not take too much into it. But it is quite interesting that we tend to see the strongest La Ninas, which are very bad bad news for a lot of the nation. Really, the whole nation gets extreme weather in La Niñas, but really impacts the central and the west quite severely. We tend to see those really strong La Niñas happen right during and towards the end of a solar minimum. We also tend to see the strongest El Niños near the solar maximums. So if we go back to that cloud idea, this theory that about cosmic rays and clouds, is it makes sense. If there's more clouds over the ocean basins, there's less solar input into the oceans, which means the oceans may cool off a bit, especially in that equator area. And that equator area is the key. During solar maximums, less clouds, because the Earth is protected more from the cosmic ray activity. Less clouds mean warmer oceans, means you're going to go through the next cycle. So what was interesting was after the year 2019, everyone's saying, oh, it's too wet, it's too wet, it's too wet, it's too wet. Well, when we get a really strong El Nino, history has shown you fall off a cliff with precipitation. And the thing is this is where it gets into planning, to where these Pacific cycles will tend to give us these periods of wet conditions for a couple, 3 years, kind of let our guard down. And then we fall off the cliff and boom. And that's really what happened in during the spring of 2020, up here till recently in terms of the drought conditions. And interestingly enough, there's a great research paper that came out about, it's maybe 2 years now, a year and a half ago, from Colorado State University Extension, that actually went back and took the sale weights of cattle from the late 1940s to present. And they then, the thing is we kind of know as far back as the late 40s, whether or not it was a La Nina or an El Nino. We kind of have to reconstruct the weather, which is a little tricky, but that's as far as we can really go. So from the late 40s to present, they found a direct, strong correlation to sale weights with La Nina and El Ninos. During La Ninas, sale weights went down. El Ninos, sale weights went up. And they basically, the premise of it was, if you're a livestock producer in the Western United States, pay attention to this, because stocking, if you just had a really wet year, let's say a couple wet years in a row, odds are higher you're going to go drier than staying wet or getting wetter. So try not to overstock during these wet periods. And then, so it's tricky, but there are some clues there.
Right. Odds are better than average that it's going to do X or Y.
Right.
Let's take a quick break and hear from our sponsor today, Farming Without the Bank. None of you are ranching like you did 100 years ago. Why are you financing it like you did 100 years ago? The biggest part of your operation is the money that runs through your hands, and you let someone else control that. The bank gets the final say in what you get and when you pay it back. For many, this is a great relationship, until it's not. Farming Without the Bank shows you how you can take back control of your money so that you can make the bank plan B instead of plan A. This is done by you creating your own banking system that you own and control. To learn more, tune into the Farming Without the Bank podcast and go to farmingwithoutthebank.com to get the book. Once you've read the book, Mary Jo will meet with you one-on-one and help you determine where and how to get started. She will most likely also touch on some estate transition ideas, financing ideas, business growth or startup ideas, and many other things that she has experience with from helping thousands of farmers and ranchers. So go to farmingwithoutthebank.com today to get the book and subscribe to the Farming Without the Bank podcast now. With the La Nina, you said that we tend to get severe weather in those La Nina years. And you didn't say dry. In my experience, La Nina means dry. Is that
absolutely
here where I'm at? It means that somewhere else it means tornado activity, or what do you mean when you talk about severe weather?
Yeah, you're right. We get everything, and that's when the weather tends to make the news more. I mean, when we saw this La Nina come, it's like, oh, we're going to hear all about this in the news, because we do tend to see an increase in tornado activity in La Nina years, in the years you move out of La Nina, kind of like what's happening now in the southeastern United States and Midwest with the tornado activity. We also it's a huge drought signal. So for California, points east to the Western High Plains, it's droughty. The only part of the country that tends to have a bit of an increase in precipitation is the far Pacific Northwest and also parts of the southeastern United States. And a certain La Nina configuration can also bring drought to the Corn Belt at times, not always, but at times as well. So it runs the gamut. It runs from increase in tornado activity, increase in hurricane activity. Hurricane activity goes up in La Ninas, and then it tends to be a drought signal. It also is a wind signal. Now, for folks who are listening that live in Kansas, Oklahoma, Nebraska, the Dakotas, the Central and Northern Rockies, if anybody remembers the spring of 2022 with the hellacious windstorms that we are having about this time of year right now, La Nina definitely has a wind signal, and that leads to higher evaporation, which makes the drought situation worse. So there's, from where I sit and stand, there's nothing really good about a La Nina if you're in the world of agriculture, because it tends to bring more stress than anything.
Yeah, there was a big fire about 100 miles north of my house. They called the Windy Fire, which burned at that time, and I have a new roof on my house as a result of that. So that 2022, spring of 2022. So can you help me understand a little bit more of this term solar minimum and solar maximum? When I hear the word solar minimum, I think less energy produced by the sun. But I kind of understood what you were saying to maybe be the opposite of that. Is what do we mean by those terms?
No, that's okay. That's true. So there's several ways to measure solar activity. One is sunspots, which definitely changes. There's some interaction with Earth's magnetic field, and that interaction with Earth's magnetic field causes it to sort of shrink and expand. And what ends up happening is during solar minimums, which is a lack of sunspot activity, and you could say that's a lack of energy too. Okay, that's fair. But what tends to happen is when the sun goes quiet, the Earth, the solar system, is bombarded by these tiny, tiny little particles called cosmic rays that hit the Earth more and they hit the atmosphere more. So in a way, what that does is that helps maybe possibly generate more in the way of cloudiness, just enough to change things a little bit. When the solar max hits, the number of sunspots go up. I mean, how many times have we seen the Northern Lights this winter? I mean, a bunch of times. Okay, so when we go into the solar maximum, which we're heading into it right now, we're the next year and a half, we'll see the solar max come on in, is that increase in sunspot activity does cause, again, the atmosphere, the magnetic field of the Earth to be more protected actually by those cosmic rays. So it can get a little bit confusing, the way it works, but the minimum basically is minimum of sunspots, minimum of activity. The Earth is more susceptible to space-based influences on our weather. And this is one thing that is a little bit of it's a pet peeve of mine, is in the world of weather and climate, there's a lot of people that just plain ignore possible influences of the sun and other, I call it off-Earth influences, that's just categorically dismissed, which I think is a big, that's a failure to think that the sun may not actually influence our climate. It's kind of like saying the furnace in your house makes no difference on whether or not you're hot or cold. I mean, it's really that silly, but unfortunately, the amount of research that's going into the solar influences on our weather is quite minuscule right now. So we need to learn more about it. Could the sun really impact the weather more than we think? Yes. Could the sun not impact the climate and weather very much? Yes. But you can't say it doesn't impact it at all, which you actually have some people saying that.
Okay, so we've talked a lot about the solar minimums and maximums, and the way I understood what you were saying was you could it's every 11 years. Like, is that you could set your alarm and say, okay, today is when we start going towards a solar maximum or minimum, or vice versa? Is it that definite?
Not that definite. I mean, you can have plus or minus months. Like, to give you an example, before we got in here, I just did a little quick research, and right now the prediction of the solar maximum could be as early as this October or as late as April 2024. Okay. So there's several months on either side of when they happen, but I will tell you this, it's pretty regular in terms of when they go through this. What is really hard to understand is, will the solar cycles be stronger or weaker than the previous ones beforehand? Because one thing that, people will talk about the little ice age that happened in the 18th century. That was a period of known very low solar activity that went for 3 solar cycles, maybe more than that. And that was a very cold period across the globe. Some people say, well, it was a combination of that, a lot of volcanic activity, which is probably correct. But you put those two together, all of a sudden you've changed the climate globally with influences of things that are hard to predict. I mean, it's very hard to predict when a volcano is going to go off. And back then, they knew about solar cycles. In fact, sunspots have been, since the telescope was invented, they've been watching sunspots going back centuries. So we do have a fairly good database of solar activity going back farther than most of our temperature records.
So somewhere around 1 million Earths could fit inside the sun. So
something like that.
Yeah. So when you start talking about something that big, just think about all the energy it takes to turn a tractor engine over, and think about all the energy, or, how long it's going to take for that process to ramp up as far as solar minimum and maximum and slow down. And so we'll give them 6 months. It's okay. Let them have that extra 6-month window to predict. But okay, then are we determining La Nina and El Nino cycles retroactively, or can we predict those on some level as well?
Well, we're getting better at anybody can tell you what happened yesterday, right? So the thing is like, well, how can we get better at this? Well, again, going back and looking at this, you do see a pattern. So let's talk about this a little bit. So what's coming for the next 24 months? So we see La Nina fading finally. It was a multi-year La Nina. It was a 3-year La Nina, which doesn't happen very often. I mean, a year ago, honestly, we thought La Nina last summer was going to go away, and it didn't. But all the signs are there. What we're seeing with sea surface temperature anomalies and everything else, that the La Nina is gone. Technically, it is gone. And we're in what's called a neutral phase, which we call La Nada, which is we're not either one just
nothing's
yet.
Happening.
But
La Nada.
Nothing's going on, right? And so we are likely going to be into technically an El Nino status as early as maybe September, or as late as probably maybe November or December. And when we tend to see those really wet springs and summers, it's when El Nino is already in place. Okay, so if we're talking about spring and summer right now, since we're not in a La Nina, that's encouraging. Okay, if we're not in La Nina, that should mean the trend as spring goes should get wetter. But the real wet spring that some of this country really needs, like Kansas and Oklahoma and Texas and eastern Colorado and parts of Nebraska and the region that are really, really droughty right now, there's help on the way, but the biggest help is probably next year using that analog technique, which is we're going into an El Nino cycle. We're also going into a solar maximum in the next 24 months. This is going to produce a strong El Nino if we just use history as a guide. Just using history as a guide. The Pacific, as we mentioned, is huge. There's nothing we can do to change it. And what'll happen after a 2 or 3 wet cycle, maybe if we get lucky 4, guess what happens? We go down on the solar cycle. We start heading towards the solar minimum. We're going to have a La Nina. Then the question is, will it be a multi-year La Nina, a weak La Nina? Will it just last a year or 2? Or are we going to have another 3-year thing? So you can kind of map out how the general weather patterns should go in a large part of the country. Now, for you folks who are listening in the Corn Belt and the Great Lakes and New England and the southeastern United States, the impacts that we talked about are less for you because you're more influenced by the Atlantic and the Gulf. But certainly for the parts of the Central and the West, it's a big, big deal.
Sure. Yeah. And you bring up some great points there. And I think that's kind of where I'd like to point towards wrapping up this conversation is it, and you've touched on this a little bit, but I'd like to take a little bit deeper dive. Is it as predictable as, okay, we are going into a solar minimum, we are going into a La Nina, I'm going to plan to have less cows around this year and for the next couple of years, and then be ready to ramp up and buy more cows in when we get to that solar maximum correlated with an El Nino? Would you say it's that? And I'm not saying Don Day said you should sell cows, you should buy cows, but is it that much of an influence and that reliable that you would say maybe that wouldn't be a bad idea to keep an eye on these things?
Yeah, absolutely. I do. And that study that I referenced, when they went back to the 40s, it's a pretty strong correlation. And I think it's enough to say, it's worth it. Now, what you may want to do if you have time, right? The problem with this experiment, so to speak, is it takes a lot of patience, because this is a multi-year experiment. And you're talking dollars and cents here, big decision. So it's a little bit tricky. But the way these cycles seem to work is that when you have the best precipitation, you have the best grass, you have the best situation. Usually what that means is you're done with it and you're going to go see the opposite happen. And then trying to time your stocking rates and everything else is a little bit tricky. However, with that said, I really recommend this paper, and I will share it with you so you can tell folks how to get it. Is it actually has a decision tree, which is if you're here in a La Nina, this is the recommendation. If you're in between years, this is the recommendation, and you can kind of start from there.
Sure. Very good. Yeah, I would love to have that paper. I'd put it in the show notes page for today so people could go there and find that. Since we are talking to people, kind of around the world, but for sure across this country and Canada, is there a network of guys who focus on their region doing what you do kind of all around the place, or is what you're doing and the way you're doing it fairly unique?
Well, it's fairly unique, but I will say that they say politics is all local, so the weather is all local as well. Right. That's why focusing on one particular area is always going to do better. So different parts of the U.S. have folks like myself. We're all a little bit different in terms of what we do. But with the advent of YouTube, if you do some searching, I've had several folks say, hey, I live in the Southeastern United States. Is there somebody like you that does something? It's like, yeah, I know a guy named James Spahn that does video weather every day that you may find helpful. So yes, there are folks out there that do tend to do this. And one trend I've noticed in the TV industry as well is that in some of the medium and larger markets, a lot of the weathermen on TV are also producing their own podcasts. They're also producing their own videos. And they tend to be region specific as well. So it may take a little bit of digging and everything out, but I tell you, I had an email once from a guy in Toronto. It says, hey, could you add Toronto? I'm like, oh, no, I can't. I'm not going to add Toronto. I can't keep it's hard enough to keep track of what's going on right now. So trying to stay put in your local area is always going to get the best results. But the amount of information that producers have now in terms of weather has never been better. In terms of what's out there, the trick is getting through the wheat and the chaff and trying to find out what's the best source of information.
Sure. Is there something that are you a Wyoming native?
Yes.
And so is there something that keeps you here? Aside from that, is the weather here your favorite weather to look at? Is it as because of the variety, it keeps you interested and engaged, or is there something else going on there?
No, absolutely. I just love this part of the country with all the recreation that comes with it. And so I like small towns, and I don't like big cities. So Wyoming's perfect for me, but it's also the variety of weather and the challenge. The challenge of forecasting the weather in this part of the country is extremely immense. And so every day when I go to work, I learn something new, and every day I go to work, it's different. So that's what's really fun about the weather.
Yeah, very good. Well, hats off to you for your work. I know a lot of my neighbors and a lot of my friends in other states rely heavily on the work that you do to help them, prepare for what's coming next. So thank you so much for that.
Thanks, Clay.
Where should I send people to get in touch with you and follow what you're doing?
If anybody has any questions, my email address is really easy. I'm don@dayweather.com, the word day and the weather put together. And then I do a daily podcast Monday through Fridays. If there's a storm coming, I will update on weekends. I post it pretty early in the morning. Most of the time it's up and loaded on YouTube. My YouTube channel is just Day Weather YouTube. And that's where you can go and look. And usually I spend about 5 to 10 minutes, depending on how much weather's going on, and basically focus on the west central and western areas of the United States.
Very good. Yep. Links to all that will be in the show notes page for today, so you can find it there. Don, thanks for your time today.
Thanks for having me.
Very good stuff there with Don. Really appreciate his time. Really appreciate his ability to articulate those things. And I think that that's some pretty useful information. So I hope it served you well. Looking forward to next week on the Working Cows podcast, going to be sharing with you an episode, another, I think, timely episode, really, that I did with Dallas Mount. And Dallas and I sat down and talked about basically what is your profit for. Now, we're looking at some incredibly high prices across the country as far as the cattle markets are concerned. I've been hearing $3,200 pairs, $3,400 pairs, $2,900 heifer, first calf heifer pairs, so very high prices, good prices on feeders and weigh ups, and looks like good prices in the fall for the calves and those kinds of things. And so there's probably going to be some money made. And I think that there was maybe some money made in 2014, 2015, and there were maybe some mistakes made at that time with how that money got spent. And so we're going to talk about what is your profit for? What do you do with the money that you're going to make this year? And how do you think about the way you deploy it strategically so that it serves you well in the long run, and so that it doesn't become a burden if you make a decision simply to avoid paying taxes. So I'm really looking forward to this conversation with Dallas, and that will be coming your way real soon on another episode of the Working Cows podcast. We'll see you then.
We invite you to visit workingcows.net to subscribe to the show via iTunes or Stitcher. You'll also find detailed show notes pages, resources from our guests, and the industry leaders who have influenced them. For more ideas on putting your cows to work for you in a more profitable way, tune in next week.